For the synthesis of luminol, 10 grams of 3-nitrothalic acid is required, which was synthesized in a previous video. Now 7 grams of hydrogen sulfate was also required, which was prepared in a previous video also. Now 10 grams of sodium acetate trihydrate is also required to proceed with the synthesis. And to help everything dissolve, 40 ml of water was also added. Later this will also be boiled off to proceed with the synthesis. Then we have to dissolve everything in the solution. A little bit of heating should also be done to help with the solvation of sodium acetate or 3-nitrothalic acid. I am not using my hot plate with magnetic stirrer as it cannot reach 200 degrees Celsius and temperatures will be going pretty high in the synthesis. So well, everything has dissolved now, giving me a pretty clear solution with a little bit of debris floating here and there, but it will not be a pretty big issue. Now, to increase the temperature, 50 ml of glycerol will be added as a solvent, as glycerol has a pretty high boiling point. After adding the glycerol, you can see that there is two layers forming. Upper layer, the reaction mixture, and the bottom layer is of glycerol. You have to stir it a little bit with your glass stir rod, and me being tricky, adding the last bits of glycerol too from the measuring cylinder. After trying to dissolve the glycerol into the reaction mixture, a little bit of turbidity will appear due to some crashing out. But soon, with a little bit of heating, everything will comfortably dissolve, giving you a very clear solution. Now you have to heat it to boil off all the water. There will be a little bit of bumping as always, as it is a mixture of water and glycerol. Now turn your Bunsen burner to full power because you now have to reach to 200 degrees Celsius. First, after 100 degrees Celsius, the temperature will spike up to 119 degrees Celsius as this is the boiling point of acetic acid and you can see the reaction. Hydrogen acetate is formed and liberating free base hydrogen which react with the 3-nitrothalic acid to form 3-nitrothal hydrazide which will precipitate like this in the solution. This is a good sign. But be careful, after the acetic acid is boiled off, the 120 degree will very fast spike up to more than 200 degree which can eventually decompose our product. So close look should be taken to the thermometer to maintain the temperature by removing and putting the Bunsen burner constantly. And the precipitate will slowly get darker and darker. Then water was added and it was filtered down. And I am working with the paste to make some luminol now. First take 10 grams of sodium hydroxide, dissolve it in 100 ml of water. To make the luminol we have to reduce the nitro group to amino group. I am just showing a small part where the 3-nitrothal hydrazide is easily dissolved in the NaOH solution. As the transferation of the product from the filter paper was messy, I didn't show it. But I obtained a very dark red colored solution. Then 30 grams of sodium diethionate should be added slowly, as this will slowly evolve a lot of sulfur dioxide and you can see the color change from dark red to a orange color. This is exactly what we want, the reduction of the nitro group to amine group. In this step the luminol is formed. But don't be like this and add extra 1 or 2 grams of sodium diethionate, as I added it and got a sulfury smell contaminant in my luminol, but it was removed laterally with recrystallization. You can also use some iron out here if you have some. Then I heated it to obtain a clear solution and filtered all the sodium bisulfate crystals and then acidified with glacial acetic acid to reach a pH of 7 and got a precipitate of luminol. After filtering it, I got 4 grams of luminol. That should be enough for my chemiluminescence demonstration. I didn't measure the actual yield. It was hovering around 30%, which was good. And now what is happening in the background is 2.1 gram of luminol, a total of 2.5 grams of sodium carbonate is added, and then water was added to let everything dissolve, as luminol is soluble in water in basic mediums. But still, due to the less amount of water, luminol was having difficulties to dissolve. So I transferred everything to a conical flask and added a little bit more of water. Then 1 ml of ammonia solution was added. And that pink color is due to phenolphthalein present, which I didn't wash properly, and it should be a no problem. You can use K4 efficiency here, but I am going with copper sulfate. and ammonia is added to keep the copper sulfate dissolved in the solution. A total of 0.2 grams of copper sulfate was added. I think I added a little bit too much. But still, everything worked fine. After dissolving it in the water, it was topped with water to 200 ml. This was our solution A, which was looking pretty nice till now. And for the solution B, we need a conical flask and added 2 ml of hydrogen peroxide 30% and then topped it up to 200 ml using distilled water. It was also pretty easy to make, and then turning off the lights and just mixing the two solutions.